All right, I hope you all had a good weekend. This is our first remote lesson. I know that I haven't had all of my geometry students doing as much on YouTube as I have my Algebra 1 and Algebra 2 students, so this is all kind of new to you. What I plan on doing is on Monday, Wednesday, and Fridays, posting a video, posting a video and having a worksheet for y'all to work on. All right, from here on out, pretty much because of circumstances, everything you turn in is going to have to be graded. So please pay attention on the email, how that I want this stuff reported. All right, first subject we're going to have is going to be right angle trigonometry. All right, I know a lot of you haven't had trigonometry before, so I'm going to address this from the perspective that nobody's ever seen it. So if you have had some trigonometry, just bear with me. It'll get a little more interesting as we go along. One of the first things that you're all going to have to get used to, and I'm going to try to leave it on the screen as much as possible, is the acronym Sohcahtoa. All right? Sohcahtoa stands for sine over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. It just is a little trick to help you remember which one of these three trigonometry identities that you want to use. All right, Sohcahtoa. Some people remember Sohcahtoa as some old hippie caught another hippie tripping on acid. There's other ones. I always found just the simple Sohcahtoa easiest to remember. All right, don't stress over this right now. You'll be able to pick up on this as we go along. I'm going to leave it down here in the right-hand corner for the rest of this video. All right, first thing I want to talk about is the actual sides. There are three different sides to a triangle. Duh. But we need to be able to label them and identify them. First, you have to remember it's a relative term. We're talking about just this angle down in the left-hand corner, the x, okay? Okay, we have to identify which side is opposite to the x, which side is adjacent to the x, and which side is the hypotenuse. All right, the easiest one is always going to be the hypotenuse. All right? The hypotenuse is always opposite this right angle sign right here. All right? That's the hypotenuse. Hypotenuse is also always the longest line. All right? Now we're going to identify the one that's opposite. Opposite is always going to be the one this angle projects on. I always look at it like a projection. All right? X projects on this side over here. So that is going to be the opposite. And finally, the last side is the one that touches the angle that we're talking about, but isn't the hypotenuse. So that would be this one down here, adjacent. All right, let's go up here and look in the upper right-hand corner. Now this is why. All these sides change now, except the hypotenuse. The hypotenuse never changes. It's always the longest. It's always the longest side, and it's always opposite this right angle down here. All right, now we're talking about y. All right, the side opposite to y is like I said for the x, is sort of like a projection. All right, the side opposite to y is down here. All right, and finally, the side that's adjacent is the side that touches the angle y, but it's not the hypotenuse. So this one is the adjacent. All right. The one thing I want you to keep in mind is you never use the trigonometric identities for the right angle. This angle down here. It's always the two other angles. So on this one, we did them for the x, we did them for the y. All right, I'm just going to jump in and do a bunch of problems similar to the ones you're going to be working on today. They're good practice problems. They'll help you get used to the wording on this. All right, we're just dealing with ratios here. We dealt with ratios in the last chapter with similar triangles. So let's look at this, sine x. All right, so I see that it wants to know the ratio of sine x. So I'm going to use this identity down here, opposite over hypotenuse. All right, so here's my x. All right, now let me identify the side that's opposite. Opposite the x is going to be 3. All right, so it's going to be 3 over, remember we're dealing with ratios, 3 over the hypotenuse to x is 5. That's your answer, 3/5. All right, that's what we're going to be dealing with today, just ratios. If you're going to be entering this in an email to me as far as an answer sheet, the way you do that is just 3/5. All right, next problem. We've got cosine y. All right, I go down to my little box down here. Cosine equals adjacent over hypotenuse. All right. Okay, we're just talking in the perspective of y here. The one that's adjacent, all right, is the one that touches it that's not the hypotenuse. All right, so it's going to be 3 over the hypotenuse, which is 5. That's your answer, 3/5 or 3/5. All right, you would write it like this on your email to me. All right, now we're looking at tan y. We're going to use this identity down here, which is opposite over adjacent. So first thing we want to do is look and see where our angle is, right? And then we're going to find the angle or the side that's opposite. Okay, the side opposite the y is the 4. So that's going to be on top. We put it just like we've got here. You know, going to make it look like a fraction, but it's actually just really just a ratio. All right, that's 4. And the adjacent, right? Adjacent is the side that touches the angle we're looking at, right? But isn't the hypotenuse. So that's going to be 3. All right, we're going back and we're going to work on the x again. All right, cosine x. Go down and check my Sohcahtoa chart. Cosine is adjacent over hypotenuse. All right, we look at the way the x is oriented. All right, the adjacent one is going to be the 4. The hypotenuse is going to be 5. So cosine x equals 4/5. All right, we're going to change the drawing here a little bit. It doesn't change the method we're doing it. All right, tan A. All right, A is down the lower left-hand side. I've got opposite over adjacent. Right, I look and see where A is. I look and find that 10 is opposite it. So it's going to be 10 over adjacent. Okay, 13 is the hypotenuse. So the adjacent one is 5. It's 10 over 5. And again, when you write this, when you type this into your email, just 10/5. All right, one last problem. So we're going to do cosine C. So for cosine C, we go down here, and we're going to use adjacent over hypotenuse. All right, so for cosine C, the angle up in the upper right-hand corner, so the adjacent is 10 over the hypotenuse, which is 13. All right? And I want you to see you can do multiple. This is a good time for me to show. I'm going to do sine C. Sine C. All right? Sine C is opposite, which will be 5, over hypotenuse, which is 13. All right? There's actually, for each triangle and for each angle, there's 3. I could go ahead and erase. I can go ahead and do tan C also. Tan C equals, all right, I go down and look. It's opposite over adjacent. So to see the opposite side is 5. All right. And the adjacent side is 10. So here on just angle C, I did all 3 of the trigonometric identities that we've talked about just on C. Rewatch this video. If you have any questions, email me. I think everybody should do fine with this if you just take your time with it. I'll have another video posted on Wednesday. Please check your emails for the worksheet that goes along with this. Got a due date for this worksheet Tuesday at the end of the day. All right. Y'all be safe, and I hope to see you all soon.